Hello, honors chemistry students. Today we are going to talk about Le Chatelier's principle. So you should have this worksheet printed up so you can do it along with me. If a system in equilibrium is subjected to a stress, the equilibrium is displaced in the direction that relieves the stress. And a stress is defined as any change which could affect the rate of either the forward or reverse reaction. So let's look at this first situation. When you So let's consider this and looking at what's going to happen in this particular equation. You have nitrogen gas and hydrogen gas reacting to make ammonia. This is called the Haber process, and this is a very important process in real life. So if you have nitrogen and hydrogen making ammonia, let's look at our first situation here. Suppose we add extra ammonia. We add extra ammonia. It's going to go away from what we add. So that means it's going to go away from the ammonia side, which means it's going to shift to the left. Let's look at the top right one. If we remove N2, if we take away N2, there's not as much N2. It's going to go toward what we take away. So once again, it's going to go toward the left to replace what we took away until it reaches equilibrium again. Our next thing is the pressure is increased. Now, let's remember that the pressure in gases has to do with how many moles of gas we have. So on the left side, there's 1 mole of nitrogen gas and 3 moles of hydrogen gas, which is 4 moles of gas. Whereas on the right side, there is 2 moles of gas. And if you remember, Avogadro let us know that if you have more gas, you're going to have more pressure. So on this side, we have higher pressure than on this side. So if we increase the pressure, if the pressure goes up, it's going to go away from what we add. So if we increase the pressure, it's going to go away from the side that has more moles. So in this case, it's going to shift to the right. And our final consideration here is if we increase the temperature. Now you notice here that this is telling us this is an exothermic reaction. So that means that heat is coming out. All right? So the heat is on this side of the equation. So if we add heat, then it's going to go away from what we add, which means it's going to shift to the left. Now pause this video and answer these, and then come back and see if you got them correct. So check your answers, and if you got them right, you can go ahead and forward the video to get to the next section. If you're not sure about some of them, you can watch as I explain them. All right, so on this one where we add the NO, it's going to go away from what we add, which means it's going to shift to the right. If we take away H2, it's going to go toward what we took away, which puts it to the left. If we add N2O, it's going to go away from what we add. So we add this, so it's going to go away from what we add. If the system is cooled, keep in mind that the heat here is on the right side, so that means we took away heat. So it's going to go toward what we took away, so to the right. If we increase the pressure, you'll notice we have 2 plus 1, which is 3 moles of gas on the right, and 1 plus 1, which is 2 moles of gas on the left. So the pressure is higher on the left. So if it goes away from what we add, that means it shifts to the right. If we remove H2, it's going to go toward what we take away, so it's going to go to the left. Again, I'd like you to pause the video and do part 3, and then come back and check your answers. Again, for each of these, remember it's going away from what is added and toward what is taken away. The two that you might not have been sure about is the catalyst. A catalyst does not affect the rate of the reaction, it just makes it begin more quickly. It allows it to hit that activation energy with a lower activation energy, but it does not affect the rate of the reaction. And here in the pressure, you'll notice you have 2 moles of gas on the left and 2 moles of gas on the right. So if you increase the pressure, it's not going to have any effect. If you have equal number of moles on both sides, changing the pressure will not have any effect. Now, pause the video again, do part 4, and then come back and check your answers. You notice the way I posted these answers, I put the arrow to the right to show which way the equilibrium shifts, and then considering that, because it asked what will happen to the concentration of water, I used that to write down what would happen. Next, again, pause the video, try part 5, and then check your answers. One you might not have been sure about is that second one, and this is the interesting thing. You can only consider the pressures of gases because the solids and the liquids are not having any effect on the pressure of your container. So in the second one, you've got 4 moles of gas on the left and 0 moles of gas on the right. So if you increase the pressure, the amount of hydrogen, this will shift to the right. So actually, let's look again. These are the arrows for which way it will go. So what's going to happen to the hydrogen in the first one? It's going to decrease. Hydrogen will decrease. In the second one, again, the hydrogen will decrease. And in the last one, the hydrogen will remain the same. No change. Now for your homework, I'd like you to turn to the back page or the second page that you've printed and complete those answers. I'll post the answers so that you can check to be sure that you've done them correctly, but please do them before you check them.